So let's talk about Ethereum. Now, you might hear that word and immediately think of a digital currency, right? But what if I told you its original vision was way, way bigger? Like building a completely new kind of internet on one single massive global computer. Before we get into all the tech, let's just start with this core question that really drove the whole project. What if trust was just baked right into the internet itself? Imagine a digital world where your stuff is actually yours and agreements just happen automatically, no need for a bank or a lawyer or any other middleman. To really get why Ethereum even exists, you have to look back at the world it was born into. Bitcoin had just come on the scene and proved that decentralized money was actually possible, which was a huge breakthrough. But it was also pretty rigid by design. It was a fantastic calculator for one specific job, money, but developers were already looking at it and dreaming of building so much more. And the vision for this new, more flexible platform came from a young programmer named Vitalik Buterin. And what's so fascinating is where the spark for this idea came from. It wasn't Wall Street. It was World of Warcraft. Seriously. When the game's developer just decided to weaken his favorite character, he felt that sting of centralized power. It was this lesson in digital powerlessness that got him thinking there had to be a better way. That personal experience directly led to the blueprint for what he called a world computer, which he laid out in the 2013 Ethereum white paper. And the goal was just audacious. He wanted to create a single, foundational platform where anyone could build and run any application they could possibly dream up, with nobody able to censor it or shut it down. Okay, but a white paper is just an idea on paper. Turning that incredible vision into a working reality, well, that meant building an entirely new digital architecture from the ground up. So how does this thing actually work? Well, unlike Bitcoin, which is really just a long list of transactions, Ethereum is what's called a global state machine. Now, that sounds super technical, but the easiest way to think about it is like one giant shared database. It holds a single snapshot of everything, every account, every balance, all the code, at any given moment. But a database needs an engine to run it. For Ethereum, that engine is the Ethereum Virtual Machine, or EVM. It's like the central processor for this world computer. And here's the magic part. It's replicated and running on thousands of computers all across the globe. Its only job is to make sure that when something happens, every single one of those computers updates that global database in the exact same way, keeping everything perfectly in sync. And what is the EVM actually running? It's running programs called smart contracts. The vending machine analogy you see here is perfect. Think about it. You put in your coin, the machine is bound by its code to give you your snack. It's an agreement that enforces itself, automatically, no person in the middle. If this happens, then that happens, period. But just as people were starting to build on this new digital frontier, the young network faced a crisis, a really big one. An event that would force the entire community to decide what it was truly all about. The crisis was all about a project called the DAO. It was this radical experiment to create a venture capital fund with absolutely no leaders, run completely by code. The hype was off the charts. It raised a staggering $150 million. And to put that into perspective, that was about 14% of all the Ether in existence at the time. But there was a flaw in the code. A single vulnerability, and an attacker found it and started draining the funds, eventually siphoning off $50 million. This wasn't just a hack. For the young Ethereum network, this was a potential extinction-level event. This just ignited a furious debate that completely split the community. On one side, you had the purists. They believed in absolute immutability, the idea that code is law, no matter what. They argued the attacker was just playing by the rules that were written in the code. But on the other side, people were saying this was clearly a disaster and they had to intervene. Ultimately, a decision had to be made, and the majority of the community chose to intervene. They executed what's called a hard fork. It's basically a software update that rolled back the clock to before the hack happened. This set an incredibly powerful precedent that defines Ethereum even today. That social consensus, what the people agree on, can actually override code in extreme cases. The minority who disagreed kept the original chain going, and that's what we now know as Ethereum Classic. So after surviving that near-death experience, Ethereum's core feature, its programmability, was about to be completely unleashed. What followed was this Cambrian explosion of new applications and new ideas. A huge catalyst for this was the creation of token standards. You can think of these as shared open source templates, almost like cookie cutters for digital assets. The ERC-20 standard made it super simple to create your own money-like tokens, which fueled the 2017 boom. And then ERC-721 came along, which provided the blueprint for totally unique tokens. You know them as NFTs. And this is where it gets really cool, because these token standards became like Lego bricks. Developers could just snap them together to build more and more complex things. And out of that, an entire parallel financial system called DeFi was born, with the goal of rebuilding lending, borrowing, trading, all of it on a completely open and transparent foundation. But all this activity, all this success, came with a huge cost. The world computer started getting really congested, and using it became very expensive. This created the next great challenge for the community to solve: scalability. The solution was one of the most ambitious software upgrades in history, something called the merge. The best way to describe it is that it was like trying to swap out the engine of a 747 while it was still in the air. They were switching the network's entire security model from the super energy-hungry proof-of-work system to the much, much more efficient proof-of-stake. And the immediate impact of that switch was just dramatic. On September 15th, 2022, the moment the merge happened, Ethereum's energy consumption dropped by over 99.5%. Overnight. People have called it one of the single largest decarbonization events of any industry in history. But the merge did more than just slash energy use. It fundamentally rewired Ethereum's economics. Under this new proof-of-stake system, people who help secure the network by staking their ETH earn a yield. This transformed Ether from just a commodity you spend into a productive capital asset. You started hearing people call it an internet bond. So this all sets the stage for the future. The vision now isn't to make the main Ethereum layer itself infinitely fast. Instead, the goal is to make it a hyper-secure settlement layer, kind of like the Bedrock Foundation. Then, all the fast and cheap activity can happen on what are called Layer 2 networks built on top. And future upgrades are all about making that connection between the foundation and the layers above it even more efficient. And this really brings us to the biggest evolution in this whole story. The goal is no longer to be a single world computer. Instead, Ethereum is aiming to become the ultimate settlement layer, a decentralized root of trust that provides security for a whole universe of other interconnected blockchains. So, from my gamer's frustration all the way to a global settlement layer, the journey of Ethereum is still unfolding every single day, which leaves all of us with the most important question of all. If this is just the foundation, what are we going to build on it next?